do next Friday, by the way, not at the end. So you get have a whole week. So hopefully you guys can fill this out. You guys don't have to put melting points or percent recoveries for the crude, obviously, because it's not necessary. We're interested in the crystallized purified forms of the percent recovery and melting point. So only fill out boxes without a line. You guys should have that already filled out. And then these are the melting for part 3, comparing at the end of the video benzoic acid with 2-naphthol, and then the mixture of the two melting points. So give the ranges. Also, in the recrystallized section for both part 1 and 2, under melting point, parentheses literature value, this indicates that I want you guys to put the melting point that was observed in the video, so the range, and then next to that, in parentheses, put the literature value of the melting point for what benzoate should be, vanillin. So do that for both parts. So melting point range from the video, observed melting point, and then literature value melting point. And then here are some questions. This question and another question are giving you solubility of compounds as the increase as a function of the increased temperature. As you can see, the solubility gram per 100 mils of water for this example increases when you increase the temperature. So then these are the questions that pertain to that. And then based off these units, you can try to solve A, which is the minimum of volume of water, to recrystallize 50 grams. So these are your grams, but in 100 mils, you should be able to do that conversion. Make sure you show work. And then how much purified glutamic acid would you expect to recover at 0 degrees Celsius, assuming no loss due to the technique? So that should be self-explanatory. So assuming no loss. And then C is a very important question. So the things that I talked about in the lab today, you should be able to answer C. And what this means is that where's the missing L-glutamic acid? So what this means is that if your crystals that you get at the end when you weigh them, you might lose some. That's something for you to think about. Where do they go? 2 is similar. You have the solubility of different solvents, water, ethanol, toluene, and then comparing the temperatures at 0 degrees and hot temperatures. You can see there's an increase in the solubility. So there's data comparing that. So then answer the question, which solvent would be the best choice for recrystallization? So this goes back to the discussion that we had in the beginning of the lab today. And then lastly, or second to last, there's an IR of one of the compounds that we quote-unquote extracted from the lab today. So similar to the IR worksheet, draw the structure of which compound out of the ones listed here this IR represent, or is represented by this IR. Draw the structure, and then label the functional groups, and then match the functional groups with the IR. So make sure you label everything and tell me why you think it's this compound based off this peak that represents or that corresponds to this functional group, etc. So just like the IR worksheet. And then lastly, this last problem is just like the problem from your experiment 2, where it's a Gen Chem type of problem. So it's similar to that, limiting reagent, predict the grams of the side reaction, the products of the side reaction. So that number 4 is. Any questions?